what is quantum physics? Quantum physics is the branch of science that studies the smallest parts of our universe, things like atoms, electrons and photons, particles of light. It explores how these tiny particles behave, interact and exist. Unlike regular physics, which explains the motion of big objects like planets and cars, quantum physics reveals that particles on the smallest scales behave in surprising and sometimes seemingly impossible ways. Particles can act like waves. One of the key discoveries in quantum physics is that particles can behave like waves. This means they don't have a single position or path like a ball rolling across the floor. Instead, they spread out and interfere with themselves, much like ripples in a pond. This concept is called wave-particle duality. An electron, for example, can act both like a tiny particle and like a wave, depending on how we observe it. Uncertainty is fundamental. In classical physics, if you know the position and speed of an object, you can predict exactly where it will go. In quantum physics, there's a built-in uncertainty. You can never know both the exact position and the exact speed of a particle at the same time. This is known as the Heisenberg uncertainty principle. It's not due to poor measurement tools, it's a fundamental property of nature at the quantum level. Particles exist in multiple states at once. Quantum particles can exist in multiple states or locations simultaneously. This is known as superposition. For instance, an electron in an atom doesn't orbit the nucleus like a planet around the sun. Instead, it exists in a cloud of possibilities. When we measure it, the electron chooses a position, but before the measurement, it exists in all possible places at once. Observation changes reality. One of the most mind-bending aspects of quantum physics is that observing a quantum system can actually change its behavior. This is often explained through the famous double-slit experiment, where particles like electrons form an interference pattern when not observed, indicating wave behavior, but act like particles when someone tries to measure or observe them. The act of measurement collapses the superposition into a single outcome. Entanglement connects particles across distance. Quantum entanglement is a phenomenon where two or more particles become linked in such a way that the state of one instantly affects the state of the other, no matter how far apart they are. If you measure one entangled particle, you immediately know the state of the other, even if it's on the other side of the universe. This has puzzled scientists and led to debates about the nature of reality and whether information can travel faster than light. Quantum tunneling defies classical logic. Quantum tunneling allows particles to pass through barriers that they shouldn't be able to cross, according to classical physics. Imagine throwing a ball at a wall and finding that sometimes the ball appears on the other side without breaking the wall. In quantum mechanics, particles can tunnel through energy barriers, and this principle is essential for technologies like flash memory and nuclear fusion in the sun. Quantum physics is the foundation of modern technology. Though it sounds abstract, quantum physics is at the heart of many technologies we use today. Lasers, computer chips, LEDs, and MRI machines all rely on quantum principles. Understanding quantum physics has also led to the emerging field of quantum computing, which aims to harness the power of superposition and entanglement to perform computations far beyond what today's computers can do. Reality at the smallest scales is strange but predictable. Quantum physics might seem weird and counterintuitive, but it is one of the most tested and successful theories in science. It allows scientists to make extremely accurate predictions and understand the behavior of atoms and molecules, the building blocks of everything. Despite its oddities, it reveals the deep structure of the universe, one that is filled with mystery, elegance, and unexpected connections. If you're enjoying the content, go ahead and hit that subscribe button, drop a like, and leave a comment. I would really appreciate it. I love hearing what you think, Hank, and your support helps the channel grow big time. Thanks for being here. It means a lot. Let's